This is a follow-up lesson for kind of an extension on what we worked on in class. So just make sure that you have your notebooks out and that you have this graphic organizer glued in, and then also these little tab parts here cut so you can kind of flap it for the foldable. So we're actually going to start with the tables first. So if you worked on some of these in class, you can of course skip over any time. I'll give you a specific instructions on what I'm going to check for next class. But anytime you feel like you need to pause the video, pause it. Sometimes I'll indicate for you to work on something on your own and then start the video back up. And kind of we'll go over the answers for those particular problems. So once you get your notebook up, we'll go ahead and fill in the first part on here. And like I said, if you worked on some of these in class, don't feel the need to watch the video at parts that we've already gone over. So for the first part, it says a direct variation between two quantities is a relationship in which the ratio of quantity to the other quantity is constant. And so that's the word we use a lot when we're talking about direct variation. There's really one main formula. Remember that y equals mx plus b is just formulas with a line. But with direct variation, we use y equals kx, where k is the constant. And yes, the k is the same thing as the slope in direct variation. So slope and k are the same thing. So basically, direct variation is any type of line, but it always is going to go through the origin. So actually, for each one of these, you could plot the points, connect them, see if they make a straight line that flows through the origin. You could also do it algebraically, which is the way that we had kind of written down in your notebook, using this equation here, y equals kx. And if you look here, checking to see if a table is direct variation means that it would fit this formula for every single point that's on the table. So for the first point here, here's your x value 1, your y value is 6. So if I wrote y using the formula y equals kx, oops, let me lock this so it doesn't do that 100 times. There we go. So I would get 6 equals k times 1. So k must be 6. So the k for this one is 6. Then for this one here, it'd be 12 equals k times 2. Well, k would still have to be 6. And remember, this is just a one step. You could divide by 2 on both sides. You can also just use logic. And then this one here, you can even see it. If I had the k was 6, 3 times 6 is 18. 4 times 6 is 24. All of these have the same constant. So for these, we're just determining if it's direct variation, and this is direct variation. So you can either put yes, you can write direct variation, whatever way you want to code that. So for this one, it's a little bit harder to tell because it's not a nice, pretty whole number for our constant. So we'll check it by plugging in 14 for y and then negative 4 for x. So y equals kx, so we're checking to see, do each one of these ordered pairs have the same constant? So we're going to plug in 14 equals k times negative 4. If I divide by negative 4 on both sides, I get k equals negative 7 halves. The next one's the same thing. So we have 7 equals k times our x value, which is negative 2. And that would give me a constant of negative 7 halves. So these both have the same constant. Once I work through each one of these, I determine that yes, in fact, they all have a constant of negative 7 halves. So for this part here, we do the same thing. We're just checking each one of these. So this would be 6 equals k times 8. If I divide both sides by 8, I would get k equals 6/8 or 3/4. So that's what the constant would be if it was part of direct variation. Let me kind of zoom in so you can see this a little bit better. Then if I plug in this one, negative 12 equals k times negative 4, my k would be 3, which is not the same thing as the constant from the first problem. So this is, as soon as you get one that's not the same, it doesn't work. Not direct variation. And the last one here, we have y equals negative 2 and x equals 32. Negative 32, excuse me. So y equals kx. So we would do negative 2 equals k times negative 32. You divide both sides by negative 32. You get k equals 1/16 once I simplify. And then you would do the same thing for each one of these here. And you'll actually end up noticing that, yes, indeed, this one, the k is 1/16, and it is direct variation. So for all of these, you're just using the same formula, y equals kx. We're just checking to see if it's a yes, is it a no. All right, so for the second part of the foldable, we can fill in. This is a direct variation written as an equation. So this equation form is the same thing in the form y equals kx, where k represents the constant. So that's the same thing. So k is still the constant. We're still checking to see, is this a straight line and does it go through the origin? So we have to have a y-intercept of 0 for each one of these. And just like we did when we were graphing lines, we want to make sure that the y is always isolated. So you can tell just by looking A, B, and C, the y is all isolated, but on D it's not. So when we get to part D, we'd have to go ahead and solve for y to check. So looking at A part, it has a slope, which remember slope and k are the same thing in direct variation. So it has a slope of 6, and the y-intercept is 0. So this is, in fact, y is by itself. This is a yes. It's direct variation. This one down here, it's y equals, so we're good on isolating the y. It has a slope of -4, but it has a y-intercept of -1. So this can't be direct variation because the y-intercept has to be 0. So this one here, C, it's got a slope of 1/2, y-intercept of 0, so this is a yes. Direct variation. And this one, like I said, we don't have y by itself, so we need to solve for y. To isolate the y, we got to divide everything by 3. That would turn into y equals 6x divided by 3, which is 2x. And now we can tell, yes, this has a slope of 2, which is the same thing as our k, and the y-intercept is 0, so this is a yes. This one here, again, y isn't isolated on E, so if I divide both sides by 5, I get y equals x over 5, which remember is the same thing as y equals 1/5 x. So those are equivalent equations. So is y by itself? Yes. My y-intercept is 0, and I have a slope of 1/5. So this would also be a yes. Direct variation. Straight line through the origin. And then the last two on here, again, this y isn't isolated, so we're going to 0 out our other term and then divide by 5. So we're going to add 15x to both sides. That's just going to turn to 0. This one's going to turn to 15x, so we get 5y equals 15x. Divide by 5, we get y equals 3x. So this has a k of 3 and a y-intercept of 0. So this would also be a yes. It's got a slope and a y-intercept of 0. And then the last one on here, G, we have to solve for y, so add 6 to both sides. Remember, we can't combine these because they're not like terms. 3y equals 9x plus 6. Divide everything by 3. Y equals 3x plus 2. So this has a slope of 3, but the y-intercept is not 0. So this is a no because we can't have that part not be 0. Alrighty. That's how you tell an equation. Just make sure that you always isolate your y. All right, for the third part of your graphic organizer template is graphing lines that are direct variation. So a graph of direct variation always is a line, and it always goes through the origin. So the same kind of information. We're still following that same formula. Y equals kx, or just y equals mx is fine too. So you're just going to graph these lines. Like I said before, if you want to pause the video for a moment and just go ahead and graph them, I'll do the first one. I can do it with you, but the rest of these, I'll put the answers up in about, just pause it, and then I'll show the answers to each one of them. So this one you start at 0, and then our slope is 3, 1, so we're going to go up 3, over 1. You can remember go negative 3 over negative 1, down 3, and left 1. So it should look like that. So if you want to go ahead and pause the video and work on the other ones, and then I'll put the answers up here after you're done. Okay. Okay, so go ahead and take a look. Here are your answers for each one of these. Notice that you can have a positive slope or a negative slope, but as long as the line's going through the origin, that's what makes it a direct variation. Okay? All right, so now we're kind of done with that. What I want you to do is, in your notebook, you're going to make 2 different columns. One of the columns, you can go ahead and literally just draw this in your notebook where it says direct variation and then not direct variation. And then that paper that I handed you in class that looks like this, you're actually going to cut these out and sort them into which category they belong in. So just to let you know, I believe there's equal amounts of each one. So there should be 6 on direct variation and 6 on not direct variation equations. So using your notes kind of from before, make sure that these you solve for y. These kind of thinking about what we talked about in class, which ones that would make sense for, and then the rest of these kind of checking points, using that table method too, and then looking at the graphs to determine which one is direct versus not. So go ahead and pause the video now, and then cut them out and sort them, glue them in, or maybe wait until after you check them to make sure they're glued in correctly, and I'll put the answer key up here. So pause the video now. Okay, so after you've glued them in, it should look like this. So when you solve for y here, it would be just 3x because I would subtract and then have to divide by -1. At the movies, $12 per ticket. This, remember, is y equals 1/3 x. This one has a constant of 2. So just to let you know, your equation for this would be y equals 2x. This one would be y equals 2/3 x. And this one's a straight line that goes through the origin. These are all ones that aren't. This would be 5 plus $2 per ride. That's definitely not direct because it doesn't go through the origin. We have a starting value of 5. This one, our x is in the denominator. It does not have a slope. So this one's a little bit tricky, but we're going to look at those next time. This one's already solved for y, y-intercept of -4, so it can't be that. This one, if I solved it, I would get -1/2 x plus 10/4, which is definitely not, it has a y-intercept that's not 0. And then here again, if I did y equals kx, I could even tell by looking at that that's not going to work at all because each one of these is going to have a different k value. And this is a straight line that doesn't go through the origin. So make sure that you have those glued in correctly on the right side. And then we'll do the last part in your notes. And these are the ones I'm going to check over all this to make sure this is done, your foldables filled out, and then also that the next part of your graph, or I'm sorry, of your notes. We're going to do 2 problems, and then that will be the end of the video. So sometimes they give you information they're not asking you to say if it's direct, they're just telling you it is direct. So if you copy this down, if y varies directly, and like I said, pause the video if you need to, with x and goes through the order pair 5, -10, write the equation of the line. So when it says equation of the line, we want to make sure that we include the variables x and y. Okay. So if it tells us direct variation, I would always ask you to immediately just go ahead and write your formula down. You have to memorize that. We're going to be using it over the next 3 class periods. So hopefully you'll feel comfortable with that. But I would write down the direct variation formula first. And then using this ordered pair, we're actually going to substitute in just kind of like we did with the table. And we're going to solve for k. So I'm going to plug this in for y, -10 equals k times x, which is 5. And once I get to this part here, I'm just going to divide both sides by 5 to isolate the k. And I find out that k is -2. Now that's great, but that's not what the equation of the line is. We have to make sure we include our variables x and y. We're still going to use the direct variation equation. We're just now going to leave the x and y in there and substitute in our value that we found out, which was k. So we're going to have y equals -2x. So that's what the answer for the equation of the line is. And this is a line that goes through 0, 0, and it also goes through 5, negative 10. Then you'll be asked a follow-up question. So using this equation, find y when x is negative 3. So we're going to use the equation we just found, y equals negative 2x. And we're going to substitute in negative 3 for x and just figure out what the y is. So we're literally just going to plug in our numbers, and we get y is equal to 6. That's it. All right, so I'm going to give you 2. You can copy these down and answer them. If you want to pause the video now, and then I'll put the answers up with the work here in just a moment, okay? All right, so I'm going to go ahead and put the answers up for the last one with the work. So the same thing. As long as it says vary directly, that means direct variation. Find your k, there's the equation, and then finding that value using the equation that you wrote. So next class, what we're going to do, I'm going to check this over, and then in addition to that, during our homework check time, instead of going over problems, we're actually going to work out the problems in the textbook that were originally assigned. So we'll work on those after we go over your warm-up. Okay? Thank you so much, and I'll see you next time.